So, good day everyone. So, I am Samantha Salvar and I will be presenting my EDA on loan approval classification dataset. So, the title of this EDA is loan approval classification, and the author is Tawi Lu, and this is his link and his profile. So, we're gonna go there and check in it. So, this is Tawi Lu. So he's the author um of loan approval classification. And this is the URL of my dataset from kaggle.com. So this is the loan application, the loan approval classification data says this is what I have chosen in the kaggle.com. So let's go back. Okay. So about the data set, credit risk assessment is very important for financial decisions. So, like deciding who gets a loan, this data set help us understand what affects loan approvals and credit scores. So, it includes details about things like credit scores, loan statuses, and personal factors. And also, using this data, we can study patterns and relationships, like which factors are most important or how different groups are distributed. And it also help us create prediction models. Like for example, we can build a model to predict whether a loan will be approved or use another model to estimate someone's credit score based on their loan details and personal characteristic. Okay, so in short, this data set is useful for understanding and predicting financial risk. So that is what about all about the data set of loan approval classification. And next we have here the data set description. So we have this data set contains a 45,000 records with 14 columns. So detailing various aspects of loan applications and applicant information. So, key features include age, gender, education, income, employment, experience, home ownership, loan amount, purpose of the loan interest rate, loan percent income, length of credit history in years, credit score, previous loan status with its approved or rejected uh, category. So here we have the data set is complete and clean with no missing values. However, the age column contains some implausible values such as applicants reported as being over 100 years old. But this data set offers a robust foundation for analyzing credit risk factors, building predictive models for loan approval, and developing regression models to estimate credit scores. So here, the first thing that I've done, we have here the gender distribution. So I have used here the pie chart to show the distribution of the gender. It's either female or male. So we only have here two genders, which is specified in the data set. So here, as we can see, the female contains 20,159 applicants. So we have that female applicants. So and also we also have 24,841 male applicants. So as we can see in the pie chart, there are more proportion of male applicants than the female. So okay. So the output shows the gender distribution of loan applicants. So here we have here a 44.8% of the applicants submitted by female applicants here, and 52.2% by male applicants. So this indicates that among the respondents, a higher proportion of loan applicants came from male applicants, while a similar percentage came from female. So To sum it up, there are 100% representing the full distribution of loan applicants based on gender. Okay, that's it. So next we have here wait. So next we have here the loan status by gender. Okay, here in the x-axis we have here the number of applicants, and in the y-axis we have here a loan status. And this colors, this bar graph, this bar represents the gender. Okay, I have mutated here the loan status because it is 0 represented as rejected and 1 represented as approved. So here we can see the female who got rejected. We have here 15,674. So this is the blue one. This is the female who got rejected, and in the female who got approved we have a 4,485. So here, this one. And in the male who got rejected, we have here 19,326. Is this the green one? These are the males who got rejected. And next, we have also here the male who got approved, 5,515. So this one, this green one in the approved part. So our analysis of loan status by gender shows that most loan applications were rejected no matter the applicant's gender. This means that more people didn't meet the approval criteria than those who did. So this trend suggests that the loan approval process might have strict requirements. Yeah, because there are lots who got rejected rather than being approved. And there are high rejection rate or limited access to loan for many applicants. So the data and visualization clearly show that rejection was the most result in this data set. So this bar graph, I have used here the Geom bar. Okay, next we have here the exploratory data analysis. So looking at the loan status. Okay. So loan status versus length of credit history in years. So, okay, I have used here the Geom Jetter. So here in the x-axis, I mutated the loan status from 0. This 0 is equal to rejected, and approved is equal to 1. And here in the x-axis, we have here the length of credit history, and the colors represent as gender. So that is the distribution. As we can see in this, it really shows that there are lots who got rejected rather than being approved. Okay. So next we have here the loan status versus years of employment experience. So in the y-axis, we have here the loan status. I also mutated the loan status for better visualization of the data. And here in y-axis, we have here the years of employment experience, and the colors are represented by gender. So as you can see, I separated the male and female to better visualize the data because there are lots. Most of the applicants, whether it's male or female, has short employment experience. That's why I decided to separate it to better visualize the data. Okay, so here we can see even if it's there is long experience of employment, that applicant still got rejected, maybe because of there is some other part of the criteria that he or she missed, or the loan approval is just really strict in its criteria. So next we have here the loan status versus income. So loan status versus income category. So here in the y-axis, there is this loan status. I also mutated it. And here we have in the y-axis part, we have, in the, wait. And this is the y-axis rather. And this is the x-axis. I think that's right. I'm sorry, sir. So in the x-axis, we have here the income category. Naman na naigun. Sorry, sir, na focus. So here, the colors represented by gender. So as we can see here, this is the high income, low income, and middle income. So I just decided to combine them. So there are in the middle income. Here is the applicants who get approved, female, male. So that's I have used here the Geom Jetter also. Next, so the findings of this data set. So the findings focus on what affects loan approval decisions. So first, we notice that males have more applicants overall, both approved and rejected. But their rejection rate is slightly higher than females. So income plays a big role in whether loans gets approved, or people in the high income group are more likely to have their loans approved, and both genders are represented equally here. So on the other hand, those in the low income and middle income groups see more rejection, showing that having a lower income makes it harder to get approved. So we also have found that having a longer credit history increases your chances of approval for both men and women. However, those with shorter credit histories faces more rejections. Okay, so lastly, when we look at these factors, income, credit history, and others, there doesn't seem to be any strong evidence of gender bias in loan approvals. So this means that approval mainly depends on things like income level, work experience, and credit history rather than gender. Okay, so that's my EDA. And now I will try to show my RMD and how did I do those things. So here, so I loaded the CSV data here, the loan approval classifications from kaggle.com. And this is the gender distribution command. So I have used the Geom bar here for this pie chart. So this is a distribution of gender. And here is this is the part of the commands of percentage of the male and female respondents. So next we have here the loan status by gender. Here we can see we've used here the Geom bar. And also here is the explanation of that. And next is the exploratory data analysis. So I've used here the Geom Jetter. So this is the visualization of this data. And next we have here the loan status versus years of employment experience. So I've also used here the Geom Jetter, and I also mutated here the loan status for better visualizations of the data. And also here, as you can see, I mutated also here the loan status and the person income, because there is a continuous variable of each income of the applicant. So that's why I mutated I have used here the income category and case when. So I've used here when, so person income is less than 50,000. So that will be a loan income. So person is greater than 50,000 if it's greater than 50,000. So and less than 100,000, that is middle income. And person is greater than or equal to 100,000, that is high income. So I have just used that way to for better visualizations of the data to show the low income, middle income, and high income. So that is Geom Jetter. I've used the Geom Jetter. So that's it, sir. These are the findings. I already explained that earlier. So that's my RMD. So I think that's all, sir. That is the EDA on loan approval classification dataset. Thank you so much.